Hello and welcome. Thank you for watching this video. We are going to see the fundamentals of Azure Cosmos DB, and in this one we'll talk about what is Cosmos DB and its advantages, what is mean by request units, what are the different APIs option we have to connect the database, and what is mean by throughput, what are the different options to define that, and what is mean by partitioning, how you can divide your data logically in case of containers. So let's first talk about Azure Cosmos DB. So whenever you develop any applications, there are requirements which you must fulfill, such as highly responsive, always online. That is, you need to have low latency and high availability. And to achieve this, you need to have applications deployed to the data centers that are close to the users. So let's take an example. Consider a city having multiple areas as Area 1, Area 2 and Area 3. These are situated few miles away from each other, and pizza company has their outlet present in Area 2. If the customers from Area 2 orders pizza, then they will receive their food early who were craving for a pizza on a Sunday afternoon. But now somebody watching an IPL match on Sunday living in Area 3 will get their pizza a little late compared to somebody living in Area 2 and will not have a great experience because of the distance that delivery guy has to cover from Area 2 to Area 3. Now the same person complained about the bad experience and the company decides to open outlets in all the areas such as Area 1, Area 2 and Area 3. Now the distance that needs to be covered while delivering pizza is less, and you will get a free pizza if not delivered in 30 minutes, so which you can consider an SLA for a pizza company. So that is just an analogy, and you can consider that if the outlets of pizza delivery is close to their users, then they can deliver the pizza early, and the customers will have a good experience. So similarly, Cosmos DB offers you a service which lets you deploy your database in various parts around the world. So you can deploy your database in multiple regions, let's say East US, West US, Central India, and all these databases are replicated and are always in sync. So this offers high availability and low latency as the data is close to the customers based on your need. And while creating the Cosmos DB account, you can specify if you need multiple regions, or you can create it later as well. So with just few clicks you can add or remove regions for the Cosmos account. Cosmos DB provides you a choice of multiple APIs including SQL, MongoDB, Cassandra, tables, etc. So Cosmos DB is a NoSQL data engine, and initially it was called the document DB, but now it is called as Cosmos DB. So whenever you create a database or a container, so you can choose one of the available options for the APIs such as SQL, table, MongoDB, Apache Spark, etc. So API basically defines how you interact with the underlying data and how the data is persisted in the store. So that is just an option for that, and API is basically an interface for the storage model, but they all map to the same technology under the hood. So you can see the different data models option we have, such as key value, documents, column family, graphs, etc. So depending on the API that you choose, you will get an experience of key value, documents, graph, etc. In Cosmos DB, you pay for the storage of data and the operation that you perform on database. So whatever operation that you perform on database consumes some amount of database resources, which is calculated or expressed in request units. The throughput is basically measured in number of request units per second on the database. So with a click of a button, you can actually configure throughput for your Cosmos account and can be scaled elastically by just a click as in when you need it. So when you define throughput for a Cosmos DB, you are actually telling my Azure Cosmos to allocate resources which can serve that number of requests per second in terms of RUs. So you can define throughput upfront using provision throughput, or also you can go serverless as well depending on the need. So in serverless, basically you will pay only for the number of RUs served, as per your need and not for the unused capacity. Also, as mentioned earlier, Cosmos DB is a low SQL data engine. That is, it is a schema agnostic. Hence, you don't need to worry about the schema and the index management for a database. So, based on what we discussed just now, we can say that the Cosmos DB is globally distributed, is multimodal DB, and which is elastic in nature and is a data engine of no SQL type. So when you are using Cosmos DB, you first need a Cosmos DB account, then you will create database, and in database you will create containers, and within the containers you will have items in it. So as you can see that the Cosmos account is basically an umbrella where your multiple databases can reside, and each of database can have their containers, and within that containers you will have the items. And also, as we discussed, there are different APIs to choose from, and depending on that, the database may uh, be called as a database or the key space. And in case of the containers, also you will have different terms that you can use depending on the API. So it may be containers, tables, collections, or graphs. And also for the items, you can call it as documents, row, or the node in case of different kinds of APIs that you choose from. So for taken if you take an example of SQL, then you will call database, and then you will call container, and then you will call it as the document. So that is how the different terminology is there for different kinds of APIs that you can choose from. Now let's talk about partitioning in Azure Cosmos DB. So in case of partitioning, the items in a containers are divided into logical distinct subsets called as the logical partitions. These partitions are formed based on the value of a partition key that is associated with each items in containers. So all the items in logical partition have the same partition key value. So for an item you will define a partition key, and based on the value of the partition key you will have the similar items present in the logical partitions. So let us consider you have a container that holds the data of employees, and each employee has unique value for employee ID. If you consider employee ID as the partition key, then consider that there are thousands of employees, so you will have thousands of such partitions. But choosing a partition key is important as it will impact the application performance. Azure scales your containers based on your logical partition that automatically manages the placement of these logical partition on a physical partition. As the demand increases, Azure Cosmos DB moves logical partition to automatically spread the load across the greater number of the physical partition. So your partition key is very important, so you need to be careful while choosing that. Now let us consider you have employee container, and you define the city as the partition key, then you will have employee partitioned based on the city of the employee. In addition to the partition key that we define, there is a one more key that is present, which is known as the item ID. So each item in a container has an item ID which is unique within each partition. Hence we can say that partition key and item ID creates the items index, which uniquely identifies the item present. So the partition key is basically same for all the items that are present in particular logical container. So you can see in first case that for the city Mumbai, all the employees will have the partition key as the Mumbai. But in case of item ID, so each of the item will have their own unique item ID. So you can say that the partition key plus the item ID will be like a primary key of for that particular item. So choosing partition key is important, which affects performance. Hence, we need to be careful while choosing the one. Your throughput will be scaled evenly across the partition. Hence, it's important as incorrect partition key may lead to the unused resources as well. So, as we discussed that your container will be scaled automatically based on the uh, partition key. So, you need to be careful about that. So there are a few things that you need to consider while choosing a partition key. So you need to choose the partition key which doesn't change much and which has a wide range of possible values. which spread RUs evenly across all partitions. So you should have the data in such a manner that it is widely spread with multiple values in a range, and also it spreads RUs evenly across all partitions. So basically whenever you are going to scale your database, so it will basically assign your RUs evenly across all the partition. So it should not happen that some of your logical partition is unused for particular logical partition. So that should not be the case. So whenever you are choosing one partition key, you should consider these things. So we discussed about throughputs, request units, partitions, but exactly what is request unit? So as we discussed that the Azure Cosmos DB supports many APIs such as SQL, MongoDB, Cassandra, etc. So each API has its own set of database operations, and these operations range from reads and simple writes to complex queries as well. So for all these database operations, there are database resources that are present, and the percentage of these resources are consumed by any database operation, and based on which request units are basically calculated. So you can think of RUs as a performance currency, abstracting details such as CPU, input output per second, and memories that are required to perform the database operations. So you can see here that there are resources present for your Cosmos DB, and percent of which will get used in any kind of database operation. So whatever percentage of resources are getting used for that particular operation, so in terms of that you will get request units. You can see this. So the request unit is basically what percentage of memory, what percent of CPU, and what percent of IOPS gets used. Depending on that, how many RUs are utilized, that is defined. So it varies from database operation, from simple write and read, or to the complex queries as well. So the cost for simple point read of 1 KB item is a 1 request unit, or you can call it as a 1 RU. Similarly, based on operation and the resources consumed, the RUs are calculated. So depending on the different queries that you use, so you will have different number of RUs that are present. So now I'm logged into Azure portal. So let's try to create a Cosmos DB. So we'll try to add one Azure Cosmos DB account. Now here you can give some basic details here. So you can see that you have to provide the resource group, account name, and then there is option for API. So you can see that the Cosmos DB is multi-model database service, and we need to choose the right API for us. So now I have selected core SQL as the API option. So you can see, so you will have multiple options here for the API. So right now I'm going for SQL, and now there is a location that you need to give. So right now I'm choosing the West US. The next option is basically capacity mode. So we discuss about the throughput. So we have a couple of options in throughput. So basically provision throughput and the serverless. So basically provision throughput is you are upfront telling Azure to assign resources based on the throughput that is present there. So, and if we go serverless, so that means that you are going to pay only for the resources, only for the RUs, request units, that you consume. But in case of provision throughput, you need to provide what exactly you need for your database. So depending on your need, you can specify how many RUs per second you need. So that's how the two options we have for the capacity mode. And then so basically if you have any free tier discount, then you will have to apply that as well. Now there are two account types, of production and the non-production. So depending on that, so you can choose one option. So this basically differentiate to control the UI experience offered in the portal
and the Cosmos Explorer. So it does not impact any runtime behavior for of the service. So it can be anything. So for now, I'm keeping it as non-production. So geo redundancy is basically an option where you can enable the global distribution on your account by pairing your region with your corresponding paired region. So your database is going to be replicated with multiple regions. As we discussed, that Cosmos is basically globally distributed Cosmos database service. So now I'm selecting enable and multi-region, right? So basically if you have multiple regions defined, then if enabling these options will enable you to specify that how many regions are right enabled. So if you want that, you can enable this option. If you not want this option, that means you will have only single region that is enabled for writing. Now next, networking. So basically all the if you want connectivity from all the networks, so you will choose the all networks option. This is basically backup policy. So different policies, how much interval you need for the backups, what are the retention policies, all those you can define here. And basically you have the encryption. So service managed key is basically the Azure will take care of encrypting your data, so that is managed by Azure. But if you want to have your own key, then you can go for the customer managed key as well. So that needs to be saved in the key vault, and you need to give the URL for that key vault. Now I'm going with the service managed key, and I'll just go ahead with review and create. Now I'm going to create a Cosmos DB account, but I already have the same account created, so I'll just skip this part and I'll just go on to this one. So now this is the account that I have created. I am now at the overview section, so you can see uh, uh, basically how you can add the containers and delete the account here. And if I just go to the replicate data globally section, so here I have defined three regions. So East US is the one that I have selected while creating it, and then I have added a second region, West US, as the pairing region. Then I have also added the Central India as a part of the multiple regions. So you can see that here you will see how many regions you have selected. So if you need to select region, so you can select from here as well. So if I just click on this one, so you will just add one more region, and your data will be replicated from for all these four regions. So, and if you don't want it, you can just go ahead and delete it from here as well. So I'll just go ahead and delete Brazil South. So that's how it is easy to replicate your data globally. So now you have three copies of your Azure Cosmos account present in East US, West US, and the Central India, but provided you should enable this option. So now if I go to data explorer here, so let's see what data we have here. I'm not sure if it has any data right now. Okay, so you can see here that we have used SQL API, so which is shown over here, and I will just expand this one. So this is basically the database that I have created, which is a GRW data, and right now I don't have any container. So what I can do is I'll just create new container, and here you can see that whether you need to create a new database or you need to use existing. So I already have it, so I'll use the existing one. Now I need to name a container, so I'll name it as my container. So what is the partition key that you need to provide? So for now I'll just keep it as partition key. Then there is an option for the throughput, so you can see that there is a manual option. So this is basically going to be the throughput that is defined on a container level, because you are creating a container. But there is a second option that basically you can create a throughput on the database level. So how many containers you have, you will distribute the throughput for all the containers. But right now I am specifying the container level throughput here. So manual is basically 400, and if we just go to auto scaling as well. So this provision maximum RUs required by this resource. I estimate your required RUs with this calculator. That means you can see how many uh, request units gets calculated for the price. So here the manual, that means that you will define number of RUs that you need for your container. So if I define 400 RUs, that means the system will allocate 400 RU capacity for my database. But if it goes beyond 400, then system will not handle that load, and you may get failure in case of that much load. And whereas the RU for auto scaling, that means system will automatically assign the resources as the load increases. So that is known as the auto scaling. So if you are not sure, then you can go for auto scaling as well. So basically this is what how you can create the container. I'll just go ahead and create one. So here we have defined the partition key, we have defined the throughput as well. So now I have my container ready. You can see the items in this section. So I don't have any items present, and you can click on new item and you can add the item over here. So by default it will create some ID, but that's just a default value for your item, but that does not necessarily be what you need. So you need to add your own JSON value or any data that you need. And the second option is your application can programmatically add the data in the item section as well. So there are SDKs available for adding the items in your containers. If you just click on scale and settings, so it will show you what settings you have for your containers. So whatever you have selected, so it will show all those things over here. So that's how the container can be defined, and you can add the items. And if you want to just query your database, so you can do is a new SQL query and just select star from and execute the selection. Right now we don't have any data, but if you have data, it will be shown over here. So that's how you can create Azure Cosmos DB account. You can create the database, and you can create the containers. Just try out and play around it. So I hope now it is clear. So that's all about the fundamental concepts of Azure Cosmos DB, and what are the database containers, items within the Cosmos DB, what are the different APIs that you have, and how you can partition your data logically based on the partition key. Thank you.